In this video, I'm going to talk about how to solve equations. And before we jump into solving, I want to talk about just the meaning of an equation. So what is an equation? Just simply, an equation is a mathematical statement that involves an equal sign that may be true for some values of the variable and be false for others. And so, for example, if you think of this equation, x plus 5 equals 6, when is that true? Well, first, it's an equation because we have that equal sign. So we have two expressions, x plus 5 and 6 are equal to each other. So we call this an equation. When is this true? What could we plug in for x? Well, it's true when x equals 1, because when we do 1 plus 5, we end up getting 6. So that makes this equation true. That's the only number it's true for. If I put any other number in, so for example, 2 plus 5, that doesn't equal 6. Okay, that equals 7, and so it doesn't work. So 1 would be the only number that works. With the equation in part B, x plus y equals 10, this is a little different because there are many numbers, actually infinitely many numbers that you could plug in for x and y, pairs for x and y that would work. So for example, maybe x is 5 and y is 5. If I do 5 plus 5, I get 10. So that works. Let's say x is 1 and y is 9. So 1 plus 9, that equals 10. So that works. I'll give you a third one. Let's say x is negative 2 and y is positive 12. So negative 2 plus a positive 12 give us 10, and so that works. There's infinitely many combinations of x and y that could work there. And there are actually some equations that don't have any solution. So for example, let's say you had the equation x plus 2 equals x plus 5. So it's an equation, we've got that equal sign there. But if we think about, some numbers that we could plug in, so the x has to contain the same number. So let's say x equals, 2. If I plug in 2 for x, I get 2 plus 2 on the left and 2 plus 5 on the right. Those sides do not equal each other. They're not going to equal no matter what I plug in for x. So there is no way that a number plus 2 is going to be the same thing as that same number plus 5. It's just never going to work. So in this case, this has no solution. So let's talk about how we solve an equation, and we're going to focus on equations with one variable. So many of these are going to have, one x or maybe one y or any other variable. So we solve an equation when we do the work to find the values that make the equation true. So we just did this above. We found values that make it true. Sometimes it's possible, sometimes it's not. Solving an equation in one variable can sometimes be done at a glance. So for example, just like above, when we had x plus 5 equals 6, I could just look at that and say, oh, x is 1 because 1 plus 5 is 6. I can just glance at that. Other times the answer is not as obvious. So maybe you have a more complicated equation where you can't just look at it and find the answer. So in that case, we perform operations that will help us get the variable by itself. So that's the goal. Let's get the variable by itself on one side of the equal sign. And then what we can do is we can add or subtract the same number to both sides of the equation without changing the solution. We can also multiply or divide both sides of the equation by the same non-zero number without changing the solution. So the rules basically are you can add, subtract, multiply, or divide as long as you do the same thing to both sides. And if you do, you keep that equation balanced. So let's jump into example 2. So we're going to solve for x, and then we're going to round to 3 decimal places if needed. So in part A, we're going to look at part A. We want to get x by itself. So right now there's a minus 2. I'm going to do the opposite to get rid of it. So if I add 2 to this side, I'm going to add 2 to the right. And if I do the same thing to both sides, it keeps it balanced. So minus 2 plus 2, those cancel out, and then I'm left with an x on the left, and then 7.5 plus 2 is just 9.5. And so our answer is 9.5 for that one. For B, x is being multiplied by 5. Well, what's the opposite of multiplication? Division. So if I divide by 5, 5 divided by 5 is just 1, so those essentially just go away. And if I do it to the left, I have to do it to the right. So our answer is x equals 14 divided by 5. And if you do 14 divided by 5 in the calculator, you get 2.8. For part C, now this one's a little bit different. We're building up here. Now we've got two things going on. We're multiplying by 3 and then we're adding 1. We're going to undo the order of operations, which means that normally with order of operations, we deal with multiplication and division first before subtraction and addition. In this case, we're going to get rid of the subtraction first. So we're going to work backwards. And I'm going to get rid of a plus 1 by subtracting 1, since 1 minus 1 is just 0. It makes those go away. And if I do it to the left, I'm going to do it to the right. So 12 minus 1 is 11. And then I'm left with 3x on the left-hand side. And then the opposite of multiplying by 3 is dividing both sides by 3. So I get x equals 11 divided by 3. I'm going to use a calculator for this one. 11 divided by 3. I end up getting a decimal. So I get the decimal 3.6 repeating, but my directions say round to 3 decimal places. So I'm going to say 667 will be I'm going to use a squiggly equals here since it's an approximate answer. I had to round. And then for D, I have x divided by 2 minus 1. So just like in C, I'm going to get rid of the minus, well, before I got rid of the plus, but I'm going to get rid of the adding and subtracting first. So I'm going to add 1, which is the opposite of subtracting 1. Minus 1 plus 1 equals 0. So those cancel out. 4 plus 1 is 5. And then I still have x divided by 2 on the right-hand side. I'm just going to write it vertically here. And then I have to do the opposite of dividing by 2. So I could multiply both sides by 2. And if I do that, then these two just cancel out. And so I've got 10 on the left equals x. Okay. And you can always double check your answer by plugging it in. That's a great strategy. So like in this example, if I just write down the equation 4 equals and then x divided by 2, instead of x, I put in 10 since that's the answer that I think is correct. And then you could even use a calculator here if you wanted to, or I'll just evaluate by hand. So 10 divided by 2 is 5 minus 1. So 4 is equal to 4. So that works. If you're still getting the wrong answer, you could always just use a calculator. 10 divided by 2 minus 1, to double check in case you were making mistakes checking. Sometimes that can get frustrating. So, remember your calculator is here if you need it. And then let's look at example 3. So we're going to solve each of the following for the variable in question. We're going to tidy up each side before we begin. So these are in their own section here, because you'll notice if we look at the right hand side where that r is, we've got a 2 times r times 4. And so when it says tidy up, it basically means just simplify this a little bit. So the 2 times 4, we can multiply that first and write this as 8r. Doing that allows us to solve using just one step now. So 8 times r, we're going to do the opposite. We're going to divide both sides by 8. So then the 8's cancel and we get r equals 5 divided by 8. And we can do that in our calculator since our directions say to round. In this case, or to write a decimal, we could get 0.625. We don't need to round. And that's our final answer. And the reason I could do that, just to back up real quick, is the commutative property. So the commutative property says you can multiply in any order. So like if you had 2 times 4 times 6, that's the same thing as 2 times 6 times 4. I could rearrange those numbers any way I wanted and I get the right answer. So that's why I was allowed to combine the 2 and the 4, even though they weren't right next to each other. And that'll always work with multiplication and addition, actually. And so let's look at B. So with B, we've got some simplifying that we can do first, and it's to add these two numbers together. So I could just do 23.32 plus 24.12, and we end up getting 47.44 minus x equals 22.31. And then now I'm going to get x by itself by subtracting 47.44 from both sides. Any number minus itself is just 0, so those cancel out. Be careful though, because you still have that minus sign is in front of the x, so I have to keep that. So it's negative x on the right hand side, and then for the left I'm going to do 22.31 minus 47.44. And so I get a negative 25.13. And then I don't want to know what negative x is equal to. I want to know what x is equal to. So you can just drop both negative signs, or the reason why this works is it's kind of like there's a -1 on the outside. So I could essentially, divide or multiply both sides by -1, which is allowed because I'm doing the same thing to both sides, and watch what happens. A -1 times negative x, a negative and a negative is a positive. So the x becomes positive, and on the left, the 25.13, that becomes positive too. And so if you have a negative on either side, you can essentially just drop those, and you've got x equals 25.13 as our answer. Okay, so let's look at example 4. So in this equation, we actually have a couple of different options, and I want to go through the different options so we can kind of see that sometimes there are multiple different ways to go about solving. And so in this equation, you've got r is being multiplied by 2, there's some addition, we've got a multiplication by 300 on the outside. There's a lot going on. So what do we do first? Well, we've got a couple of options, like I said. So I'm just going to write down option 1 here, would be to take, so I'm going to write down the equation again. We could do what's called distribute, or use the distributive property. Take this 300 and multiply it by both terms inside the parentheses. So that would give us 405 equals 300 times 1 is 300 plus 300 times 2 is 600r, or 300 times 2r, I should say. And so then we can solve this just like our other equation. So I'm going to subtract 300 from both sides, and that gives me 105 on the left and then 600r on the right. And so then I could divide both sides by 600. Okay, the 600s cancel out, and then I get 105 divided by 600. Okay, and I get an answer of 0.175 for r. And then the other option, so option 2, I'm just going to write down my equation again, is I could just get rid of that 300 right off the bat. It's being multiplied since it's written outside those parentheses, so I could divide both sides by 300 as my first step. And that cancels the 300. It completely removes it from that side. And then I could do 405 divided by 300. Okay, so I get a decimal of 1.35 on the left, and then 1 plus 2r on the right. And at that point, you can just drop those parentheses since there's nothing on the outside that's needing to be done to them, what's on the inside. And so then at this point, I could subtract 1 from both sides. And so I get 0.35 on the left, or 0.35, and then 2r on the right. And then last step, I divide both sides by 2. So you could take 0.35 divided by 2, and I get the same answer that I got before, so 0.175. Okay, so 2 options, both are great. You just pick whichever one resonates with you.